Hey everyone, sorry, excuse me. What we're going to do today is kind of go through. Um, I had two parts on this because we're going to go over this. I'm going to explain the natural, what they use. They use the common thing, the um, most common isotope. We'll discuss next week and part of the assignment on what that means. So we have two parts today. We're going to explain the homework over the weekend, and then we're going to explain this part. So this part's going to go first, and then I'll explain the homework over the weekend. Okay? So my expectation is that you do that. So this is part D. I'm going to start on the back. There's actually two parts. I'm going to pause it. This is part one, and I'm going to come back to that because I'm going to explain it a little bit more. That's where I boo-booed yesterday. And I gave you guys this assignment when you needed one more step in between, and I didn't have that worksheet handy. So make sure you guys get that for yesterday. Do that first before you can do this. Okay. Second of all, let's see if it's on the screen. Oh, and then here's the second part. So I'm going to go ahead and start with letter E first. I think I can do this. How awesome is that? So excited with that. I'm not going to do letter D. That's okay. So I'm going to go ahead and get my pencil thickness down. So the nuclear symbol is what we were using. You have the mass number and then the atomic number. So carbon is, and I apologize because my handwriting is going to be really bad. Carbon is the symbol. So if you have problems with that, and I know most of these pretty well, and I'll go back and do another one. You need to get out a periodic table, always, always. And I'm just going to pull one up from online. Carbon is C. If you notice, the mass number is 12, so we're going to just write that right up here. If you have any problems with that, you need to look at different videos. Now, I need to look at how many protons what's the atomic number for carbon. I don't like how they put an atomic number at the end because it should be at the beginning. I apologize. I look on the periodic table, it's the whole number, and it is 6. This 12 is also on the periodic table, but it's not the same 12, okay? Again, if you need help with that, go to the other one. Then that's always the number of protons, and this is a neutral atom. So if you have problems with that, you need to go back and build an atom, okay? And so that will equal 6. Whoop, I apologize. Let's see if I can't go back. Oh, I can. And that's 6. Okay, yes, the atomic carbon has a lot of 666 with it. It's just what it is. Okay, now I need to put the atomic number down here at the bottom. Okay, pretty simple. The nuclear symbol is really cool because I just take 12 minus 6. The mass number is 12. It's just the number right there. That's how we write the isotope symbol, is you just put the mass number at the end. It's 12, and then so 12 minus 6 is 6. Okay, so in this case, they're all the same. That's not the case normally. I'm going to do one more for you. We've got nickel right here. I know it's nickel. I'm not going to pull it up. You need to go look. Let me see if I exit the drawing. Okay, where's my Ni? Oh, and I needed it anyways. Well, kind of in this case because I needed the atomic number. I don't have nickel memorized, okay? But I know that Ni is nickel. All right, so I'm going to remember this number, 28. Oh, there's a 58.6. That's weird. Not really worried about that right now, okay? All right, I'm going to go back to the sheet. Okay, so I have nickel. I'm going to go ahead and get my drawing. It's 28 and 60. That's 68.6. That's not the same number because we're not worried about that decimal quite yet. We're going to learn that next week. So there's no way to start and stop on this, okay? But I know that this is the atomic number. And I also knew that from the periodic table. Atomic number is always the number of protons. And right now, because it is a neutral atom, I'm going to change the color on this to blue, that it's the same, but we don't want it to be the same because that is not what happens. And if we didn't have that concept, we wouldn't have life. Okay. All right. Now I need to find, oh, here's the mass number. I'm going to go ahead and just get a different color so you can see that. Where is the mass number? Not on the periodic table, but on right there. Okay. And so you take 60, subtract 22, and that would be 42. Man, is that right? Nope, it would be 32. I thought that was a little off. See? I just needed to, you guys can do simple math. So 60, there's no multiplication, subtract 28. And I even, like I said, I just boo-booed. We have 5. 10 minus 8 is 2. 5 minus 2 is 3, so that's 32. Okay, that's all you do. Now, what's the name? I want you to capitalize it. N-I-C-K-E. It's very hard to write with that. And you got to put the mass number at the end. Where's the mass number? Oh, it tells you. Okay, all right. Okay. All right, so that's this part here. All right, I'm going to go ahead and click out of exit drawing. I'm going to leave that for just a minute. Okay, and if you need more, go ahead and pause it. One of the things here is 13. Remember, it's a neutral atom. So for right now, this would be the number. This would also be the atomic number. Okay, and I'll leave it there. Okay. I actually, off the top of my head, don't know what element 13 is, or 16. I do know that, or element 19. I know what it is, but you guys need to use the periodic table to understand that. Okay. All right. I'm going to go ahead and I'm going to exit drawing. You can pause here if you need to copy those down. All right. So this bottom part down below, atomic number for iron 56, that's on the periodic table. Mass number for boron 11, it's right there. It's not on the periodic table, it's right there. How many protons are found in strontium? Now, this is one, I don't remember if it's SR or if it's ST, so you've got to go through that. Number 6, look at the amount of protons. That will tell you what element it is. Next one, it will tell you what element it is, but you need to write it in the nuclear isotope symbol. Okay. Let's go down to number 10. It says, based on the periodic table, what is the most common isotope of mobilium? And that's going to be the meat of the lesson today. We kind of talked about it here. I'm not going to explain where that comes from, but we're going to discuss this, okay? So this will go up to number 1 up here. It says part A. So this is what we kind of have to go over. I'm going to go pause it. And I've got some math concepts, but no true math. I mean, there is math concepts, but we're not going to be, it's kind of going to be learning about the 3-throw, but we're not going to be doing the 3-throw and the only way to get this, guys, is just to do. You can't just sit and do it once. It's like throwing a free throw. Yes, you could study it. Yes, you could do it, but you got to put pencil to paper. Okay. All right. So it says part A, the most common isotope in the hyphen notation for the following elements. The most common isotope can be found by rounding the atomic weight found on the periodic table elements to the nearest whole number. So here's the key words. So the most common isotope can be found by rounding the atomic weight on the periodic table to the nearest whole number. Let me see if there's any tricky ones. There's one tricky one, and that is chlorine. Okay. All right. And chlorine's just really unique. So what you're going to do is we're going to use Spaghetti Mountain. You need your periodic table on this. And again, I'm going to change this. Nope, I need highlighter, and let's see this color. I'm going to color a highlight over that. The most common isotope. That is the key thing here. You quite don't understand this because I have to go over it next week, but you can at least use the tools to find it out. You don't understand the background, but you can find out what it is, okay? So if you notice that we have sodium, sodium is Na. If you need to highlight that, go ahead and pause and highlight that. I am going to go get on a periodic, or I'm going to exit this, okay? So the most common isotope is basically on the, excuse me, on the PT, okay? It's on the periodic table, okay? Because of its abundance, okay? In the natural world. All right, but like I said, we can't really explain, you can't know what's going on until next week, okay? All right, so if I go and I have, I'm gonna go ahead and just get this going here. Let's see, I'm gonna draw this out, but I want black. If I have carbon and I have two numbers, I have a 6 up here, and then I have a 12 point, I think it's 0, 0, 1. On this case, what you have is this number, and we're going to round that number, okay? Now we're going to look at Spaghetti Mountain here, okay? And if we have, and we're going to talk more about this next week. If I have, this is in between 12 and 13, because it's greater than 12, but barely, and then we have 13. So where would that be at? Right there. And so this whole closest number is going to be 12. Okay. All right. So if I go to, I'm going to exit, I'm going to leave this here for a few seconds if you need a pause. Okay. And then I have boron. Okay. Okay, I said boron if I didn't, but I meant sodium. So this is going to be in between 22 and 23. Where's the spaghetti at? Really close to 23, so it's going to roll down to 23. So that is just like our assignment. I'm going to give you a few seconds with this. I'm just running out of time. So that's why it would be sodium, the symbol Na. Here is just, you're going to use the most common one on the symbol, but you're going to write the nuclear symbol notation. We kind of did these down below, but it's just using your periodic table again. So hydrogen 3, H3, has 1 proton always. This one you take 1 minus 3 and is a 2. Now, is this the common one? No, because you got to go back to that periodic table. Here's hydrogen, and that's that 1. So it is not the most common, okay? What I recommend for you guys to do is just get through this. Beryllium, let's go to beryllium real quick. Beryllium, protons would be 4. It's 9, so it's going to be most common is the 9. But on that case, it has 6 protons, okay? It has 6 protons. So 10 minus 4 is 6. Is that the most common? No, because it's 9. All right, so try to get through as much as you can. If you have questions, come see me. This is why it's good to do this. I'm actually going to post another video concerning tomorrow's or this weekend's assignment. All right, bye guys.